Okay, so once again, good morning everyone. So our topic for today is about concurrency, no, mutual exclusion and synchronizations. No? So in this lesson, we're looking forward to understand the concepts related to concurrency such as race conditions, OS concerns, and mutual exclusion requirements. We will be able to understand hardware approaches to supporting mutual exclusion, define, explain semaphores, monitors, and explain the reader's-writer's problem. Designing correct routines for controlling concurrent activities proved to be one of the most difficult aspects of system programming. No, we experienced that, especially in an object-oriented, no, in database specifically, no, data mining or data warehousing, or even through our design and algorithm, right? Now, the ad hoc techniques used by programmers of early multi-programming in real-time systems were always vulnerable to subtle programming errors whose effects should be observed only when certain relative rare consequence of actions occurred. So the errors are particularly difficult to locate since the precise conditions under which they appear are very hard to reproduce. The central themes of operating systems design are all concerned with the management of process and threads, no, including the multi-programming, multi-processing, and distributed processing. So fundamentals to all of these areas and fundamental to OS design is concurrency. So concurrency, because concurrency encompasses a host of design issues, including communications among processes, sharing of the competing core resources such as memory, files, and input-output access, synchronization of activities of multiple processes, and allocation of processor time to processes. So we shall see that these issues arise not just in multiprocessing and distributed processing environments, but even in single processor multi-programming systems. So the concurrency arises in the three different contexts, no? Multiple application, structured applications, and operating system structures. So to give us more details about the topic, let us all welcome our presenter. Okay, go ahead. Go ahead.
Concurrency, communication among process is made up of four key components. The components include encoding, medium of transmission, decoding, and feedback. The communication process begins with the sender and ends with the receiver. The sender is an individual, group, or organization who initiate the communication. Sharing resources. Sharing resources is computing a shared resources or network share is a computer resources made available from one host to another host of a computer network. It is a device or piece of information on a computer that can be remotely accessed from another computer transparently as if it were a resources in the local machine. Synchronization of multiple processes. Process synchronization refers to the idea that multiple processes are to join up or handshake at a certain point in order to reach an agreement or commit to a certain sequence of action. Allocation of processor time. is the amount of time for which a central processing unit was used for processing instruction of a computer program or operating system as opposed to elapsed time which include, for example, waiting for input output operation or entering low power mode. Difficulties with concurrency. Sharing sharing global resources. The ability to all of the users of a local area network to share any of the resources connected to the network. Management of allocation. Lang, sir. Management of allocation resources. Programming errors difficult to locate. By far, the most difficult error to find is the logical error. A program can have a logical error due to mistyped formula or due to an incorrectly implemented algorithm. A simple example for con- ano to? Ano to? Programming errors. And operating system concern. Keep track of active process, allocate and delocate resources, processor time, memory, files, input-output device, protect data and resources. Process interaction type. Processes completely unaware of each other. Processes indirectly aware of each other. Process directly aware of each other. Computation among processes for resources. Inclusion. Execution of one process may affect the behavior of computing processes. If two processes switch to access the same non-shareable resources, one processes will be allocated the resources and the other will have to wait. Non-shareable means cannot be used simultaneously by different processes. Control problems. Mutual exclusion achieved using critical section. Only one program at a time is allowed in its critical section. Example, only one process at a time is allowed to send command to the printer. The deadlock starvation. Cooperation among processes by sharing non-shareable resources. Process use and update shared data such as share variables, files, and database bases. Write, Writing must be used mutually exclusion. Critical sections are used to provide mutual exclusion on data. Cooperation among process by communication. Communication provide a way. Paano mo muna? Communication provide a way to synchronize or coordinate the various activity. Possible to have deadlock. Each process might be waiting for a message from the other process. Possible to have starvation. Two processes sending message to each other while another process wait for a message. Requirement for mutual exclusion. Only one process at a time is allowed in the critical section for a resource. If a process halt, halts in its critical section, it must not lock out other process forever. A process required in the critical section must not be delayed indefinitely, no deadlock or starvation. Requirement for mutual exclusion. Process must not delay access to critical section when there is no other process using it. No assumptions are made about relative process speed or number of processes. A process remain inside its critical section for a finite amount of that of time only. Busy waiting. Example, in ig- igloo was small entrance, so only one process at a time. May enter to check a value written on the blackboard if the value on the blackboard is the same as the process may proceed to the critical section. Example for igloo formula terms. Busy waiting problems. Process must strictly alternate in their use of their critical section. If one process failed, the other process is permanently blocked. Each process should have its own key to the critical section, so it was in one process is eliminated, the other can still access its critical section. BT waiting second attempt. Each process can examine the other's status, status but cannot alter it. When a process wants to enter the critical section, is check the other's processes first. If no other process is the critical section, it sets in status for the critical section. Example for busy waiting second attempt. Busy waiting third attempt. Set flag to enter critical section before checking other process. In another process is in the critical section when the flag is set, the process is blocked until the other process release the critical section. And the example for third attempt. Busy waiting for attempt. A process set its flag to true to indicate the desire to enter its critical section but is prepared to reset the flag. Other process are checked. If they are in the critical region, the flag is reset back to false and later is set to indicate the desire to enter the critical region. This is repeated until the process can enter the critical region. And the example for attempt. This is waiting correct solution. Each process get a turn at the critical section. If a process can the critical section, it set its plug and may have to wait for its turn. Must combine the turn and plug variables. Mutual inclusion interrupt disabling. A process runs until it invokes an operating system service or until it is interrupted. Disabling interrupts guarantees mutual exclusion problems, limit the processor in its ability to enter live program, efficiency of execution could be noticeable, degraded, multiprocessing, disabling interrupts on just one processor will not guarantee mutual exclusion. Mutual exclusion machine instruction. One special machine instruction is used to up- update a memory ca- cannot interpret. This can be used for single and multiple processors. Can be used for multiple critical sections. Sample test and set machine instruction. Mutual exclusion machine instruction. Disadvantage. Other process must use by busy waiting while trying to execute test and set. Disturbation is possible when a process leaves a critical section and more than one process is waiting the next processors to execute test and set chosen randomly by hardware. Deadlock is possible if a low priority process P1 is in the critical region and higher priority process P2 needs CPU. P2 will obtain the processor. If P2 now wants to enter the critical section, it will block it because P1 is still in critical region. Semap Semaphores. Special variable called a semaphore is used for signaling. If a process is waiting for a signal, it is suspended until that signal is sent. Wait and signal operation cannot be interrupted. Q, Q is used to hold processes waiting on the semaphore. Semaphore example. Use of binary semaphore, each process. Implementing semaphore using test and set. And an example. And procedure, consumer problem. One more, one more producers are generating item and place them in the in a butter. A single consumer is taking item out of the butter one at a time. Only one producer or consumer can access the butter at any one time. Two semaphore are used. One represent the number of items in the butter. One signal that it's all right to use the butter. An example for procedure and consumer function. Infinite butter. Um, and and one of the example for consumer process. Monitors. Much higher level synchronization construct than semaphore. Only one process is allowed to execute inside the monitor at any given time. Other processes are suspended while waiting for the monitor. Processes can be used suspended while in the monitor. In this case, the process enter a monitor by calling one of the monitor's procedures. Process leaves a monitor when done or when suspended on con- conbarred. Process can use conbarred signal before leaving, which make wakes up which wake up some process previously suspended on conbarred. Okay, next. An example for monitoring infinite butters. Message, message passing. Use to enforce mutual exclusion, enhance information, message passing synchronization. Sender and receiver may or not be blocking for intents. And debius block. When debius, blocking send, blocking receive. Both sender and receiver are blocked until message is delivered. Non-blocking send, blocking receive. Sender continues processing such as sending messages as quickly as possible. Receiver is blocked until the requested message arrives. Non-blocking send, non-blocking receive. Addressing, direct addressing. Send primitive include a specific identifier or the destination process. Send receive primitive could not know ahead of time from which process a message is extended. Receive primitive could use source parameter to return a value when the receiver operation has been performed. Indirect addressing, message are sent to a shared data instruction consisting of those are called mailboxes. One process sends a message to the mailbox and the other process pick up the message from the mailbox. Fourth is a mailbox assigned to a specific process, typically general message format. Reader-writer problem. Any number of readers may simultaneously read the file. Only one writer at a time may write to the file. When a writer is writing to the file, no reader may read it. An example using message passing. Sir, okay na po.
Okay, so as what our presenter mentioned, no, the central themes of modern operating system are multi-programming, multi-processing, and distributed processing. So fundamental to these themes and fundamental to the technology of operating system design is concurrency. So when multiple processes are executing concurrently, either actually in the case of multiprocessor system or virtually in the virtually in the case of single processor multiprogramming system, issues of conflict resolution and cooperation arise. Concurrent processes may interact in a number of ways, as what our presenter presented earlier. Processes that are unaware of each other may nevertheless compete for resources, such as processor time or access to input-output devices. Processes may be indirectly aware of one another because they share access to a common object, such as block of a main memory or a file. Then finally, processes may be directly aware of each other and cooperate by the exchange of information. The key issues that arise in this interaction are mutual exclusion and deadlock. Okay, so the mutual exclusion is a condition in which there is a set of concurrent processes, only one of which is able to access a given resource or perform a given functions at any time. When we say mutual exclusion techniques, it can be used to resolve conflicts, such as competitions for resources and synchronized processes so that they can cooperate. Let's say, for example, or an example of the latter is the producer-consumer model, in which one process is putting data into a buffer and one or more processes are extracting data from the buffer. One approach to supporting mutual exclusion involves the use of special purpose machine instructions. This approach reduces overhead, but it is still inefficient because it uses busy waiting. Another approach to supporting mutual exclusion is to provide features within the operating system. And two of the most common techniques are semaphores, as what our presenter mentioned, and message facilities. No? Semaphores are used for signaling, no, among processes and can be readily used to enforce a mutual exclusion discipline. No, messages are useful for the enforcement of mutual exclusion and also provide an effective means of inter-process communications. Okay, so the readers have priority, of course, no, as what our presenter shown earlier, no, that the solution does not change for multiple readers and writers. So the writer process is simple. So the semaphore or WSIM is used to enforce mutual exclusion. As long as one writer is accessing the shared data area, no other writers and no readers may access it. So the reader process also make use of WSIM to enforce mutual exclusion. However, to allow multiple readers, we require that when there are no readers reading, the first reader that attempts to read should wait for WSIM. So when there is already at least one reader reading, subsequent readers need not wait before entering. So the global variable read count is used to keep track of the number of readers, and the semaphore X is used to assure the read count is updated properly. So I think that's it for the topic.